what we have here is a car of mass m is traveling on a straight road. The power output is a constant 25 m watts. Now, there's a formula for power. Power equals the force that's moving your object and its velocity at the same time. So power equals force multiplied by velocity. Okay, new formula. Now, your force times velocity is therefore equal to 25 m. Okay. Now what we're going to get next, guys, is we're going to isolate out. We're going to put isolate out f. F equals. It's going to be m a v equals 25 m, and therefore a on its own is going to be 25 over v. Now you have to make a choice on which integral are we going to use. Are we going to use the v dt, or are we going to use phi times the v dx or the v ds? Have a look through. The speed, so we're talking about speed, so we have v and find the time taken. So the time taken is t. So we have phi and t. So we're going to use the v dt. So we're going to have the v dt ends up to be 25 over v. Cross multiply. Phi times the v equals 25 to t. And once that's done, we're then going to introduce the integral signs. Now, car speeds up from 1 to 3. What does that mean? You can put 1 and 3 here if you want. It'll get you the answer directly. In general, what we do is we tend to keep the top integral the same, and we'll substitute in 3 later on. The choice is yours. Okay. Then the other part is what is it? T and 0. So I think I did it all in one go, but it doesn't really make a difference. Now we get phi squared over 2 when you integrate from phi to 1, and then we're going to get 25t from t to 0. We're going to get 25t, and we're just going to get phi squared over 2 minus 1 squared over 2 equals 25t. Now, at this point in time, it's probably a good choice not to isolate v on its own. The whole point is you're looking for the time, yeah? So you might as well put in your upper integral of 3. So it'll be 3 squared over 2 minus a half all over 25t, which is going to be, what's it, 9 over 2 minus 1 over 2, which is going to be 4. 25t, and then cross multiply down, t equals 4 over 25. I made the decision not to isolate v because the whole point of the question was to get t on its own, so it's just better off just to put the integral in. That's the first question done, guys. It's that easy. Next question after that. An engine pulls a train. The train works at a constant power of 25 km/u subscript 0 squared, where m is the total mass of the train and the engine, and k and mu 0 are positive constants. Show that the equation of motion is v squared to v equals 25 k u squared ds. Now, see the v, see the s. We're thinking phi to v ds. It's the only way to get those two integrals lined up together. Then we're going to go for the f equals what's it? F equals f. Oh, sorry, P equals Fv. Your power outage equals your force times the velocity you're going at. Now, and what we're going to say is that equals 25 k u squared. Then F is MA. MAV equals 25 k mu squared. The m's can just disappear. Okay. Isolate A. A equals 25k, what's that, mu subscript 0 squared all over V. Now we're going to choose phi times the VDS equals 25k mu squared over V. We cross multiply the V on the bottom. So that phi goes up to create phi squared. The ds goes up, so it's phi squared dv equals 25k mu squared ds. And that is there. Now, we can see that we proved the first question. Now we're going to go down. A distance traveled as the speed. Find the distance traveled. So we're finding s as the car speeds up from mu 0 to 4 mu 0 is 21 mu 0 over 25k. Now we're going to go phi squared dv equals 25k mu 0 squared ds. Find the distance travelled. So we start the clock off at 0 because we're assuming no distance has been travelled to get to this point. We're only looking for the distance travelled in between speed 1 and speed 2. That's why you can set your lower limit to 0. Okay? Then your upper limit will be s. And then what we can do here next is phi squared dv is 4 mu 0 on top and mu 0 on the bottom. Integrate. Phi cubed over 3. 4 mu 0 to mu 0. Yeah. And then the other one. These are all constants, aren't they? Everything there is a constant, or claimed to be a positive constant. So it's just going to be 25k mu 0 squared, and then there's just going to be an s lobbed in at the end of it. And then that's from s to 0. Finally integrate this, and we're going to get a 4 mu 0 cubed over 3 minus mu 0 cubed all over another 3. 25k mu 0 squared, and then s being the purpose of the question. It's going to be 64 mu 0 cubed over 3. Take away one of them, isn't it? So that'll be 63 mu squared over 3. Oh wait. And that in turn is 21 mu squared 3 cubed. 25k. Why is there an extra 0 there? Mu 0. There wasn't a squared there, was there? Oh, there was a squared. Times s. Now, the whole goal is to isolate s and prove it's this here. I think we're pretty close to doing that now. Mu squared cancels with mu cubed, just leaving one mu 0 on the other side. And then the 3 is gone. Sorry, when I divided 63 by 3, the 3 on the bottom disappeared. Then bring over to 25k. So 25 mu 0 over 25k equals s. That we're asked to prove? Yeah. Okay. Now, a car of mass 1 ton moves along a horizontal road. The engine works at a constant rate of 75 kilowatts. Now, that is P is going to be equal to FV. FV is not equal to 75. It's equal to 75,000. They try and get you with the K. Kilowatts. They didn't specify K as a constant, did they? They don't say K as a constant anywhere in the question. Because they don't say that, it means it has to be kilowatts as opposed to a constant watts. Now, we isolate F, it's going to be MAV over 70, and then 75,000. Whoa, wait a second. Ah, this time, what is M? 1,000. So it's going to be 1,000 AV equals 75,000. We'll isolate A. So A equals, bring down 1,000 V underneath. What would 1,000 V do to that? You make it 75 over V. So, just want to do that. So it's 75 over V. Make a selection. Show that the acceleration of the car is 75 over M. Okay, that's done. How long will it take to speed up from 5 to 25? Now, how long? Is that referring to distance or time? How long? That's time. Why is it not distance? Yeah, that's the only leading question, really. The other one is how long can be distance or time? So I'd have an inkling it's time. So it always gets me sometimes how long. The V to T ends up to be 75 over V. Then we get phi to V equals 75 to T. Integral 5 to 25. Now it doesn't say anything about starting off at it doesn't say anything about starting off at 0 or anything like that, does it? No. So 5. We're just going to put the 25 for the top integral because what happened last time is going to happen. We're just going to have to put it in anyway. Then we're going to have a t on 0 on the bottom, t on top. Why is it 0 on the bottom? You're looking for the time in between the two of these. So you're not counting time it took to get to 5 in the first place. You want the in-between time, in between 25 and 5. That's why you always set your lower limit as 0 when you want an in-between. Does that make any sense? So, what's going to happen now, guys, is we're just going to integrate. Haven't been here before. Phi squared over 2. That's 25 over 5. Make that 5 a bit more 5-like. That's a 75. So it's 75 t to 0. 25 squared over 2 minus 5 squared over 2 equals 75t. I think that's going to turn into 300 equals 75t. Bring the 75 underneath. T equals 4. You okay? Alright with that, guys? T equals 4. Now, we next have to do distance. Now, we can relate the distance. Directly to the speed using the second integral, the other choice, so to speak. So, whoop, that didn't turn out as flush as I would have liked. Oh yeah, we don't need that part. Crap. Zero part's gone. Now, what we have here is what distance does it cover in this time? So what distance does it cover? So, what we're going to do instead of using the VDT is we're going to go for phi times the VDS. And that's our new acceleration. And it equals 75 over V. We cross multiply to get phi squared to V equals 75 ds. Now, we integrate both sides. What distance does it cover in this time? The distance in between those two speeds sets the lower limit as 0 and the top limit as the distance we're looking for. The speeds are again 5 and 25. It's a different integral than last time. Last time we were in, so it's going to be phi cubed over 3 from 25 and 5, and the other one's going to be 75s from s to 0. Now 25 to be cubed over 3. Take away 5 cubed over 3 equals 75s. Put that in your calculator and you get 15,050. Sorry, 15,500 all over 3 equals 75. Is that 75s or 75t? 75s. I just wrote down t for some reason. Divide by 75 and you get the distance taken is 68.89 meters equals to s. And you're done.